Hey, Algebra 2, today we're going to learn how to solve log equations. So we haven't had you graph a logarithm, but I will tell you that this is what it looks like. So there's my x-axis, there's my y-axis, and there is what the graph looks like. So down here, when we did other graphs, when your graph kind of makes a turn and it starts like basically running parallel to something, so this is an asymptote. And there is an asymptote here at x equals 0. And so because there is an asymptote, there will be no negative x values. So that is why you cannot take the log of a negative number, because if we had made you graph it, you would probably have a better understanding. Another fun fact is if b is a positive number, so yeah, you got to take the log of a positive number, log base b of x equals log base b of y. So if you have the same base right there, you can drop them and set x equal to y. So when you have the same base, you're going to drop log. We did this same thing on exponents because exponents and logs are related to one another. Like back a few sections ago, if you would have had 3 to the x equals 3 to the 5th, you have the same base, and so we would set the exponents equal. So that's basically the same thing that we're doing here, just with logarithms now. All right. So you can't take the log of a negative number. That means the domain is x is greater than 0. Can't take log of negative number. So example, if you have log base 2 of negative 5, this is what no solution would look like. So you're like, okay, where's this can't take the log of a negative? Where would that show up? It would show up right there, right there. Cannot have a negative right there. All right, so I want to solve this equation. Log base 2 of 2x equals 3. So you're going to have a couple of different scenarios. Right here, we have the log equals a number. This is the scenario that we have going on. Log equals number. Anytime this is your setup, what you're going to do is change form. And when I say change form, it's in log form now, so therefore you're changing to exponential form. So I have log base b of x equals y, and the exponential is b to the y equals x. So I don't know how to solve it in log form, therefore change to exponential, and hopefully you can. So when I change form, the base is 2, the 3 moves over, and that equals 2x. 2 to the 3rd equals 2x. All right, so we're not going to overcomplicate this. 2 to the 3rd is just simply 8. And all you got to do is algebra, divide, and so x equals 4 in this case. We have another scenario. So in this particular scenario, I have log base 3 of something equals log base 3 of something. So I have these logs are the same. So when you have the situation of log equals log. You're going to drop the logs and solve. So the stuff in parentheses, the x plus 17 and the 3x plus 23, those are the two components I'm going to set equal to each other. X plus 17 equals 3x plus 23. Do some algebra and solve the equation. So we move our letters to one side, subtract the x. Move your numbers to the other side, subtract 23. 17 minus 23 is negative 6. 3x minus 1x is 2x. We're going to divide both sides by 2 and get x equals negative 3. All right, so let's check this. Because when you plug it in, you cannot get a negative number where those yellow highlights are. That would be you can't take the log of a negative number. All right, so I have log base 3 of negative 3 plus 17. I have log base 3 of 14. And then on the other one, I have log base 3 of 3 times negative 3 plus 23. 3 times negative 3 is negative 9. Negative 9 and 23 adds up to 14. And so log base 3 of 14 equals log base 3 of 14. So this is okay. So just because you get a negative answer right here doesn't mean that you're going to say no solution. That's not what I care about. That is what I care about. After you plug it in, you got to make sure that that is a positive number right there. On the next one, I have log equals number. So anytime you have the scenario log equals number, I'm going to change form to solve it every time. So when I change to exponential form, my 4 comes down, my 5 halves goes into the exponential position, and the x crosses over and goes to the other side. From here, this is actually just pure calculator work. So in your calculator, you're going to hit 4, the caret, your exponent there. So you're going to go 5 divided by 2, close your parenthesis, and hit the enter key. And that is how you get x equals 32 for a good final answer on that one. Next one, number 4. So I have log minus a number equals a number. So I don't have log equals log or log equals number yet. So your first move is to isolate the log on one side. So therefore I'm going to have to add 5 to both sides before I can do anything else. Log of 4x plus 2 equals 2. All right, so now I have the situation that I did on the other side. I have log equals number. When I have this situation, you need to change form. So when you change from log to exponential and you drop and swap, there's no base here. So now you have to remember that there is an implied 10. So now when you change form, your base comes down, your 2 goes to the exponent, and your 4x plus 2 goes to the other side. 10 squared I know is 100. And now from here you should just be able to do basic algebra. Move your numbers over. Get 98 equals 4x. Divide both sides by 4. And I'm going to go ahead and use a decimal. So I get 24.5 equals x. So you got to remember, when there's no base, it is an implied 10. That is something that you need to remember. Number 5, I have log equals log, okay? So when you have log equals log, you're going to drop the logs and solve it. So that means you have x squared minus 4, that 3x is 1 unit together, equals 3x. Okay, so now you have a quadratic. We've done quadratics. Quadratics have to be set equal to 0, so therefore you should subtract 3x over. X squared minus 3x minus 4 equals 0. So you're probably making an ACB chart literally or in your head. I need factors of -4 that add to -3. So I have -4 and 1. So from the factor form, now you need to set them equal to 0 and solve. So that means x equals 4 and x equals -1. I got 2 answers. I should definitely start checking. All right, so first we're going to work on checking x equals 4. So I have log base 2 of 4 squared minus 4 equals log base 2 of 3 times 4. 4 squared is 16. 16 minus 4 is 12. 3 times 4 is 12. All good on that front. Now, we are going to check x equals -1. So I have log base 2 of -1 squared minus 4 equals log base 2 of 3 times -1. -1 squared is 1. 1 minus 4 is -3. And 3 times 1 is also -3. Part of you probably wants to go, yep, -3 equals -3. I am good to go. However, your stopper is right there. You can't take the log of a negative number. Therefore, we are going to have to cross out -1 as a possible answer and write extraneous. So actually, x equals 4 is your only good answer. And last one. So I have an expression, so this 3x minus 5, that is traveling together as 1 unit. And so I have a log here equals an expression or a number. So I am going to do log equals number. And anytime you have log equals number, you need to change form. So when I change form, and it's kind of backwards too. We haven't had the log on the right side. So either A, you can try it and it'll certainly work, or if it makes you more comfortable, you can go log base 2 of 1024 equals 3x minus 5. So now when you change form, your base is 2. The 3x minus 5 goes to the exponent. And the 1024 goes to the other side. All right, so here is where you would like to get like bases. So you're asking yourself, can I write 1024 as 2 to the something exponent? And you can. You just have to play in your calculator a while. And that is 2 to the 10th. So 2 to the 3x minus 5 equals 2 to the 10th power. My bases are equal, so you're going to drop them. and set your exponents equal. Now I'm just going to solve. I'm going to go plus 5 to both sides. 3x is 15 divided by 3. And x equals 5. All right, and technically you can do it another way. So this we're going to call option A. Option B, I showed you the change of base formula yesterday, but we haven't done much with it since then. All right, so on the right side, I have a 2 and a 1024. So anytime that you have a number in both spots, you could always use your change of base formula because you can get a number right there. So that's my plan. So I have 3x minus 5. And so the change of base formula that I learned yesterday, log of 1024 divided by log of 2. So we changed it to a base of 10. You got to just know that the big number is bigger and it wants to stay on top, and the little base, it's just going to drop and go to the bottom. So in your calculator, go log of 1024, enter, divided by log 2, enter. And your calculator will come back and tell you that that is 10. Same thing that we got when we did it here using like bases. And then we're just going to go through the algebra. We're going to add 5 and divide and still get x equals 5 for a good final answer. I will see you in class.